Hi, here we are discussing refraction by a lens and lens makers formula. So first of all, we can imagine our object is at O and it incident on a double convex lens, and the image I is formed on the other side of the convex lens. So this figure is depicted in the diagram. So this we can say that the geometry of the situation. So here what we are imagine is we can split the situation into two. So we can say that at first the object arise from the object incident on ABC, the refracting surface. Second, we can imagine after that happens, the image again is recreated or regenerated to the next surface of ADC and forms an image there. So we can say that at first an image due to ABC is formed on the other side. Then we can say that due to the second image there is an image formed due to ADC in the ADC part of the convex lens at the other surface. So first just we can think that object is at O, and from the object there is an ray of light coming from to the refracting surface, and it forms an image at I1. Here R1 is the radius of curvature, and you can say that when we use the equation 9.15 in the previous section to this case, so we can say write the equation as n1 by OB plus n2 by BI1 is equal to n2 minus n1 by BC1. So this equation is from that 9.15, and we can use this situation, this equation here to get the idea. So here n1 is the first refracting medium in the situation, n2 is the second medium, that is glass we can take as the second medium, and BI1 is the distance of image distance in the second medium, and OB is the object distance in the first medium. So BC1 here is just a refractive index, there is nothing in this one. So this can be considered as equation number 1. So this is very useful relation, and we can consider the next case as a simple case of this one. So we can say that this is second medium ADC. In this second medium ADC, second surface ADC, object is I1 and image is I. So here you just imagine this I1 is formed at the second refractive index of the medium, second refractive medium of the first diagram. So we can say that this is formed, I1 is formed at N2. So when we use 9.15, we can use the same equation here. Here we can write minus n2 by di1. Why it is minus n2 means negative is because the ray is traveling from the right hand side to the left hand side, from I1 to the refractive index. So it is against the ray of incident ray light. So we should take it as a minus 1. So minus n2. So why n2 means in the previous diagram image is formed at the second surface, that is why n2. So n2 is minus n2 by di1 plus n1 by di is equal to n2 minus n1 by dc2 is the second equation. This is from the diagram itself. For thin lens, we can consider bi1 is equal to di1, because the distance, the difference is very small, so we can neglect that. So we can take it bi1 is equal to di1, and adding equation number 1 and 2, we get n1 by OB plus n2 by bi1 minus n2 by bi1. So these two terms cancel, those rounded in the equation, those cancels. The remaining is n1 by di is equal to n2 minus n1 into 1 by bc1 plus 1 by dc2. So left hand side there is an n1 by OB and plus n1 by di. So we can consider, we can take this n1 as a common factor and we can take it outside. That's a very simple procedure and you can do that yourself. And if you take this n1 to the other side, we will get n2 minus n1 by divided by n1. That is also very simple. Here what we are mentioning is, this is very simple equation to understand why we get this equation, because in this diagram we can say that I1 is a object of this diagram, and we do not want to consider that terms in this equation, because we do not want to consider the virtual image formed in the process. So that is why we just omit y1. Suppose in this figure we just imagine the object is distance placed at infinity, and dA is equal to then it will be formed on the principal axis. That is why it is called principal focus. That is why it is focal length of the image. So we can say that dA is equal to f. So first term in the previous equation cancels and second term becomes n1 by f, and we can write n2 minus n1 into 1 by bc1 plus 1 by dc2. By sign convention we can say that bc1 is equal to plus r1, positive r1, because it measures in the direction of incident light. And second situation, dc2 can be considered as minus r2, because we can consider the distance against the incident light, so it is minus r2. And if we substitute this in the above equation and first equation, we get n1 as we can take that n1 to the other side, so it will become 1 by f. 1 by f is equal to n2 minus n1 whole divided by n1. So n2 in the first time we get n2 by n1 with minus n1 by n1. So n2 by n1 becomes n21, and minus n1 become minus n1 by n1 becomes 1. So here the equation is 1 by f is equal to n21 minus 1 into 1 by r1 plus 1 by r2, where n21 is equal to n2 by n1. This is known as Lensmaker's formula. So for concave lens also we can use this equation. R1 we can take it as negative, and R2 is positive, and f is negative for the concave lens. First the equation remains the same, only some terms will get a negative sign. Thank you.